Critical Lens Lab by Julie, Yashnan, and Kim. Introduction. A convex lens is a lens that has at least one surface that curves outward. It's thick at its center and thinner at its edge. This lens is also called the converging lens, as it causes light to converge inwards without bringing the ray together at the focal point. A convex lens close to the object will create a magnified virtual image of the object. If the lens is further from the object, it will produce an image that is real, upside down, and can be projected. The size of the image formed depends on how far away the lens is from the object. In this lab, we are going to find the focal length of a convex lens. In order to do this, we will use the lens formula that states 1 over u plus 1 over v equals to 1 over f. Aim. The purpose of this lab is to determine the focal length of a convex lens. In order to do this, students will use equipment with a convex lens and the image it creates when placed in front of a candle. Materials. In this lab, we will use a tea candle, a screen which is a cardboard, a laptop, a convex lens, some matches, ruler. Procedure. First, light the candle, hold the lens in front of the candle and in between the board and candle. This is so that the lens will reflect an image of the candle on the screen. Second, move the lens and candle until a clear image of candle is visible on the board. You need a clear image in order to attain precise data of U and V. Then measure the U, the object distance, and the V, image distance. You need U and V in order to find the focal point using the thin lens equation. Then record the data and repeat 40 times using different distance to create a clear image on the board. The more data you have, then you can plot a graph and get a precise focal length. Graph and analyze your data. Graph in order to find the line of best fit and then with the most probable focal length. Error analysis. In this lab, there were several sources of error that might have hampered our experiment. First of all, the biggest difficulty we faced was to determine what U and V stand for. Initially, we thought U is the image distance. However, after checking, and we saw there's no correlation between U and V in our graph. We went to search, and then after some research, we found out U was actually the object distance and V was the image distance, and we corrected. Additional, it was really hard to judge which screen position or lens position would form the sharpest image, as the image was really dim. This was a major source of error because if we measure the unclear image, our data would be significantly affected. Another error was that we were not able to obtain exactly precise data due to the unstable disk. Even though there was only 1 or 2 millimeter difference in measurement, and that did significantly affect our data in focal lens lab. It is always essential to obtain the most precise data in an experiment. A possible improvement in this lab to reduce errors would be to do more this research and get familiar to the basic procedure and concept of focal lens lab. Also, next time we could use more stable data to do our experiment on. Moreover, instead of using a meter stick, which made it really hard to measure, we would use a medium-sized ruler to obtain more precise data.